Hi everyone, this is Notes 62. So today we're starting with something called rationals, and all that really means is that we're dealing with fractions that have x's in them. So you should already be done with your warm-up and your stand and talk. So let's go ahead and get started. So we're simplifying rational expressions. So in order to do that, we need a new vocab word. That word is rational expression. And all that it means is a fraction or ratio of two polynomials. Remember, polynomials are just numbers and variables. Numbers and variables. Right, so an example might be like x plus 2 over x. Or another example might be x squared plus 4x minus 8 over x plus 2. Right, so basically just a big old fraction. So we have steps to simplify. We're going to factor the numerator and the denominator. We're going to eliminate common things. We are going to simplify it. And then we're going to determine the values for which the expression is undefined. These are also sometimes called excluded values. These are the things that it cannot be. So basically the big things we're going to do today are factor things and cancel stuff. That's it. Factor things, cancel stuff. So if I'm looking at this one here, I'm going to look at the top part here. I'm going to rewrite my fraction. And I know that I can factor this. I see x squared, x, and 3. I know that I can factor this using the x factor. So my 3 things that multiply to get 3 and add to get negative 4. I know that 3 is 3 and 1. So I know negative 3 and negative 1 would make negative 4. So I have x minus 3 and x minus 1. So that's the top part there. I also know that I can do the same thing to the bottom part here because I have x squared, x, and a number. So I know that I'm multiplying to get 5, adding to get negative 6. That might be negative 5 and negative 1 because those multiply to get 5, add to get negative 6. So I'm going to have x minus 5 and x minus 1. So first step was to factor things. We did that step here. Now we're going to cancel stuff. So I'm going to look for things that are the same. So I can see that x minus 1 and x minus 1 are the same. So those can cancel out. So I can say, all right, those are the same there. That means that I'm left with x minus 3 over x minus 5. I cannot cancel my x's because they're attached to subtraction. So I know that this is my answer. However, the last piece, this number 4, determine the values for which the expression is undefined. Something is undefined if it's divided by 0. You try to divide anything by 0. 10 divided by 0, 20 divided by 0, x divided by 0, negative 100 divided by 0, anything. All of these things are going to be undefined. So we need to be careful to see where is my equation going to be negative 0. So this here, this one is not allowed to be 0, which means that x is not allowed to be 5. So I'd say x is not allowed to be 5. I also have to check this one, the other denominator. So I have x minus 1 is not allowed to be 0. I'm going to add 1 on both sides. So x is not allowed to be 1. If you remember flipping the signs, that's kind of what we're doing here, but we're just making sure that x is not allowed to be those numbers, because it is, then our answer doesn't work. So this whole thing is going to be our answer. Every time we write an answer, we're going to write the excluded values as well. So our answer is there, and these are what we call excluded values. Okay, so let's try another one. That was number 4. Number 5 is below. Yep, it's right there.